Everyone, at this point we've looked at what a 1-1 function is, and we saw how we have this updated hierarchy where we have relations, and then we have functions, and then we have 1-1 functions. So going from relation to function means that we require that every input has exactly one output, and then from there to 1-1 function means that we require that even every output is associated to a unique input, and that's why the name 1-1, meaning one output for one input and one input for one output. Now the reason we introduced this notion of a restricted function called 1-1 function is to help us study another class of function which is very important and useful, and this is called the inverse of a function. Now you are familiar with inverse operations. In the week 1 videos there were, like, when you solve an equation you use inverse operation, like the inverse of addition is subtraction and the inverse of subtraction is addition, or the inverse of multiplication is division and the inverse of division is multiplication. So this already gives you an idea why looking for these inverses or defining inverses is important. It's because inverse operations, they cancel each other out and they help us solve equations. Now recall that as a machine, y equals f of x can be viewed as this following diagram. That there's a box, there's an input flowing into it. The input is denoted by x and the output is denoted by y. So in this case, we see that the input flows into the function and the function returns an output. So when we think about just naively what an inverse would mean, so inverting here would mean we exchange the input and the output, which means we are looking for a function into which we feed the output and we ask, what do you think, or can you figure out what was the input that gave the particular output? So this tells us that while a function answers the question, what is the output if my input is so and so, inverse function answers what was the input if my output is so and so. So it answers a different question, but that different question is derived from the original question. And so let's look at an example with some special values. Now let's say you're given that a function f behaves as such: when the input is 1, the output is 5. When the input is 3, the output is 7. And when the input is 8, the output is 10. So it goes like that, it goes like that, and goes like that. Now to find the inverse of the function, what that function, the inverse, written as f to the power -1, and we read that as f inverse. So now if my input is 5, it's going to give me as output 1, which was the input in the previous case. So you see how the input and the output have been flipped. In the same manner, asking what is f inverse 7 implies asking what should the input be for the output to be 7, and that is 3. Similarly, f inverse of, let's make this positive 10 would be 8. So that gives me a pair of value which is just flipped. The x and y values have been flipped. Okay, so for example, here is a function. Let's say the inputs are given as 1 and then 4 and then 3. So if you have to draw the machine diagram for f inverse, then your inputs are going to be 1, 4, 9 and your outputs are going to be 1, 2, 3. So that the f inverse gives us exactly the opposite. Alright, the inverse of a function f is written as f inverse, and we read this as f inverse or inverse of f. Now naturally, because we are switching x and y, right? Now what does x represent? X represents the input and y represents the output, which means that by switching them, we are also naturally switching the domains and the ranges. So the domain of x becomes the range of f inverse, and the range of f becomes the domain of f inverse, right? Because remember, x, which is the set of inputs, and all the valid ones are called domain, and then y, which is the set of outputs, and all the valid ones are called the range. So now if I were to switch them, right, what would happen? If I switch them, then I'm basically saying that my domain now is here and my range is here. Right? So what was my domain became the range, and what was my range became the domain. Relation between a function and inverse function. If f is a 1-1 function with domain A and range B, the inverse function f inverse satisfies the following cancellation properties. Now what is the motivation for this? Remember inverse operation, add, subtract, multiply, divide. The reason they were important was because when applied one after the other, they would cancel each other out. Right? So similar thing happens with the function. We write that notationally as saying f inverse of f of x is x for every x in A, where A is the domain, and f of f inverse of x is also x for every x in B, where B is the range. Now let's unpack this definition. First of all, f of x, right? This is defined only if x is in the domain of f, that is in the set A. Now whatever this gives me, f of x, that is in the range of f, that is it's in capital B. And then if you apply f inverse to this, remember, because it's the inverse function, the range is the same as the domain of f inverse. So this is valid. It is valid to put f of x into the input for f inverse. And this comes out to be x. Now in the machine terms, what that happens is you're taking the function x, input, output, and you feed this output into f inverse, you're going to get back the same input. These are going to be the exact same. And even if you were to switch it, start with the output to get the input and feed that into f, you would get the same output. Meaning that if you feed an x in this system, you get back an x, and if you feed an x in the second system also, you get back an x. Okay. that was the theory behind what an inverse function is, what does it do, how it interacts with the actual function, how the cancellation laws work. Now, that's going to be the end of this video, and in another video we are going to then look at the computational part, meaning how do you find the inverse, how do you check something is an inverse, what does it really mean graphically. All of that is going to be in another video. Thank you.